Today we're going to be talking about evaluating algebraic expressions. When I say evaluating an expression, I really mean simplifying it to get down to just one answer. So you're going to see an expression like 3x plus 4y, and we're going to be given values for x and y. We're going to replace those variables. We're going to substitute numbers in place of those variables to figure out what this equals when x equals 2 or y equals 3. So you replace each of those letters with those values and evaluate the expression. You figure out what that equals. So a variable is a letter or symbol that represents the unknown number. Once you know the number, then you can substitute them in. This is an expression. Really, this is an expression. This is an expression. Any mathematical sentence is an expression. Evaluating it is the process of replacing those variables with those given numbers. And then simplifying it means we're reducing it into the simplest form. So sometimes that means combining like terms. Sometimes that means evaluating. You're really just trying to make it as simple as possible. So when we're evaluating expressions, we're going to use order of operations, or GEMDAS. And when we do this, we're going to rewrite each of these variables, each of these numbers in place of the variables in parentheses. So anytime we substitute a number in, it gets its own set of parentheses. So I'm going to rewrite this. Nothing else is changing except this x is turning into -4, and the -4 gets its own set of parentheses. Then I'm going to follow order of operations, or GEMDAS, from here. So G stands for the grouping symbol, which means I need to do inside the grouping symbol first. 9 minus -4 is 13. These grouping symbols, these straight up and down lines, are called absolute value. It's basically just thinking about this number as a positive. Since it's already a positive, I don't actually need to change the number. I'm going to change them into parentheses just to show that I'm multiplying here. You're not going to see the multiplication symbol there. Same thing here. But there's an implied multiplication. When you have a number outside of a grouping symbol, that is implying that we're multiplying those two together. So -2 times 13, that's -26, plus 7, that is -19. That is evaluating an expression given a replacement value. That is as simple as that expression will get. I'm going to do the same thing here. I'm going to replace the a and the b with these values. 6 minus 2 times 10. Again, each number is going to get its own set of parentheses as we substitute it in. These big fractions, whenever you see something like this, that actually is a grouping symbol. And really, even more specifically, the top and the bottom are grouped separately. We're going to solve everything on top first, everything on the bottom, and then divide those two numbers. So we do everything on top, everything on the bottom, and then just treat that as division. 20 divided by -5 is -4. I'm writing parentheses there not to show multiplication, but just to distinguish between these two symbols. I don't want to write those two right next to each other, so I just want to put that in parentheses just to show that it's separate. Now I can evaluate that last part. 6 minus -4 is 10. The good news is, you do need to be familiar with GEMDAS. There's going to be times where you're asked questions directly about steps in GEMDAS, but last year you did not have a calculator. This year you do have the calculator for this entire unit. It's going to be really helpful. We can just directly assign values to variables. So we could say r equals 3. So this is our original problem. R is 3, s is -5. We're going to type those in separate lines. R equals 3, s equals -5. And then we type the expression exactly like we're shown here. You don't change anything about that. You just retype it, and it evaluates it for you. All right, I'm going to show that on a couple examples here. The only time we really need to be careful, really, Desmos is doing all of that thinking for us. The only time we really need to do anything for ourselves is when we have a fraction like this, and we're writing our answer in fraction form. Now, that's not always the case. Sometimes decimals are okay. Here, we're going to try we're really just going to practice here, so I want you to write these as fractions. So in place of each of these variables, we're going to substitute these in, but we do not need to do that by hand. Oops, that's not right. All right, so a equals 5, b equals -3. So when we're dealing with a fraction and we want our answer in fraction form, we're going to type everything on top and evaluate just that part of it. So that gives us negative 34. Actually, sorry, I don't want to really write that there. The top of the fraction is negative 34. The bottom is just a times b. That's negative 15. And then I want to simplify this fraction. Actually, nothing divides these two, but they both have negative signs, so you could divide them by negative 1 on top and negative 1 on the bottom, and just change it into a positive version of each of those numbers. That is as simple as that will get. So when we want our answer in fraction form, we're going to type the numerator in one line, the denominator in another, and then write it as a fraction and simplify it. This one will not require that. There is no fraction sign here. So I'm going to clear everything out. If you keep those, it's going to still think b is negative 3, but we're changing b to negative 2. So we want to change that out. A is 3, b equals negative 2, and then we'll type our expression. When you're using that square root symbol, it's important that you hit the right arrow there. If you don't, you're going to still be stuck inside that square root symbol, but you can see that the b to the third power is outside of there. So when we replace those values, we get that. That whole expression evaluates to negative 15. All right, I think you could try the rest of these on your own. Plug these in carefully. There are two things that I need to point out. These braces, Desmos misunderstands what that is. It's like when we listed out domain and range, when we list out a set of numbers, that's really what those are used for in Desmos. So we have to change those into parentheses when we type those into the calculator. The second thing, this letter E, when you type E into Desmos, it gives you a decimal immediately. It's kind of like the number pi. It's just a stand-in value for that letter. So we have to change this also. If you're given a value of E, let's change that to X and substitute like that instead. All right, try those U-tries on your own.